Good evening. Today class we are going to see about how the BJT is going to be modeled by using H parameter equivalent circuit.
So first we have to consider the two-port network. So two-port network means which consists of two input terminals, and we will be having the two output terminals also. So here the input voltage what we are given to the two-port network is considered as marked as V1, and the input current is going to be taken as I1, and then the output voltage is going to be taken as V2, and here the current we have to represent it as I2. Okay. So in this two-port network, so any two variables need to be considered as dependent variable, and another two variables need to be considered as independent variable. So in this case, we will be considering the V1, and then I0 or I2 is considered as a dependent variable, and then here II and V2 is considered as independent variable. So here, so we have to write the equation for the H parameter equation for the dependent variable as a function of independent variable. For example, here there will be two dependent variables are there. So the first one is V1, so that is for your input voltage, and then the next one is going to be for the output current, that is going to be I2, that is the output current. So for this, so here we have to write both the equations. So by means of the independent variables, so that is going to be the function of two independent variables. Here as per this discussion, so here we will be having the two independent variables, that is actually II and V2. So here also for the output current, so we have to write the equation. So by means of these two independent variables, so that is your II and V2. So if we are considering the H parameter model, so we will be having the four specific values. So that is actually H11 and H12 and then H21 and H22. So these are all the different variables. So which is used to represent the input impedance and output admittance and the voltage gain as well as the current gain. So in which we will be writing the equation. So based on this dependent variable and independent variables using these H parameter values. So for that we will be writing the equation for the input voltage. So that is going to be V1 equal to H11. So the first independent variable is going to be II plus the next H parameter value is going to be H12. So the next independent variable is going to be V2. So that we have to consider as the first equation, and followed by we will be writing the another equation for the output current. So that is going to be I2 equal to, so the next H parameter variable is going to be H21. So the same independent variable we have to take. So that is going to be II plus H22 V2. So that we are considering the second equation. So from this we will be find out what is your H11 and what is your H12 and what is your H21 and followed by what is H22. So first we have to consider, so this is actually the H parameter model. So the H parameter model means it is the term itself, the meaning is that it is the mixing of your the short circuit as well as the open circuit. Okay. So here the output circuit is going to be considered as a short circuit, and the input circuit we have to port we have to kept in the open condition. So under this case, so the output voltage is going to be 0. So like that here the input current is going to be 0. So by considering these two cases, when the output voltage is going to be 0 as well as the input current is going to be 0. So by applying the same thing in the equation 1 and equation 2, we will be getting the different value of H parameter. For example, if you are considering the output voltage V2 equal to 0, so that need to be applied in the first equation. So we will be getting, so suppose we are substituting V2 equal to 0 in the first equation, we will be getting H11. So the H11 we are getting is going to be V1 by I1. So V1 by I1. So by considering the output voltage is going to be 0, that is nothing but V2 equal to 0. So here we will be getting the voltage to current ratio. So that is nothing but impedance. So that is nothing but, here this is also input port and this is also the input port. So that this is nothing but H11 is nothing but input impedance. So input impedance. So the unit is ohm. So either we can write the same equation by means of representing the input. So that is nothing but input impedance. So that is going to be V1 by I1. So the same scenario here also. Here V2 equal to 0. So that is by substituting your V2 equal to 0 in the first equation. So now we have to substitute the same in the second equation. We will be getting H21. So H21 is going to be, so I2 by I1 we are getting. So here also we have to consider, so the output voltage V2 equal to 0. So here it is the ratio of output current to the input current. So that we will be having, it is nothing but current gain. So that is also, we call it as, it is a forward current gain. So that can be denoted as HF. That is going to be I2 by I1. So here also the V2 value is 0. So this is by substituting your output voltage equal to 0 in the equation number 1 as well as the equation number 2. So now we are going to substitute the input current equal to 0 in the both equations. So that what we are getting, the first case, suppose we are substituting I equal to I1 or IA equal to 0 in the first equation, we will be getting H12. So H12 is going to be V1 by V2. So V1 by V2 by considering the input current I1 equal to 0. So here if you look at the ratio of this numerator and the denominator, we will be getting the input voltage to the output voltage ratio. So that is nothing but, here it is a reverse voltage gain. So that this can be denoted by HR. So that is going to be V1 by V2. So the same condition, I1 equal to 0. So now we are substituting same I1 equal to 0 in the second equation. Here we will be getting the another particular value. So that is going to be H22. So the H22 is going to be I2 by V2. So I2 by V2 when we are considering the input current equal to 0. So here we will be getting the ratio of current to the voltage. So that is belongs to the output port. So that we can take it as output admittance. So that is going to be H0 equal to, so I2 by V2 when the input current I1 equal to 0. So we will be getting the four terms. So one is denoting the input impedance and another one is denoting the output admittance and another one is forward reverse voltage gain and then forward current gain. So here we can rewrite the equation based on this particular notations. For example, here we have replaced the H11 by Hi and H21 by Hf and H12 by Hr and then H22 by H0. So we will be having the another modified form of these two equations. So that is going to be V1 equal to H11 is become Hi Ii plus H12 is become Hr into V2. This is your third equation and the another particular modified equation is going to be I2 equal to H21 can be replaced by Hf into Ii plus H22 is going to be denoting the output admittance, so that this can be replaced by H0 into V2. So this we may take it as the fourth equation. So based on these two equations, we can able to write the H parameter equivalent circuit. So for example, here we will be having the voltage. So that, for example, this one is your RHS side, LHS side. So this one is your RHS side. Suppose in the LHS side we will be having one particular quantity. In the terms whatever is present in the RHS side also supposed to be the same quantity. For example, HI denotes the input impedance. So this can be represented by the voltage to the current ratio. Here also you will be having the current. So that this current and this current is getting cancelled. Here we will be having only the voltage. example, here we will be having the HR. So that is indicating the reverse voltage gain. So that can be represented by V1 by V2 ratio into here already we are having the V2. So suppose this V2 and this V2 is getting cancelled, we will be getting only the voltage term. So that the here the total voltage is nothing but the addition of these two voltages. So now we are coming into the second equation. So suppose the HF indicates the forward current gain. So that is nothing but output current to the input current ratio. So here the IA is going to be, you have to keep as it is. For example, if you are cancel out these two things, we will be getting only the current.
So that is going to be H naught. So that is actually the output current to the output voltage ratio. So that is nothing but it is going to I2 by V2 ratio into V2. So here also these two are getting cancelled. So here also you will be having a output current. So the output current here, the equation for what is present in your LHS side is going to be same as the same what is present in your RHS side also, right? So now we will be going to draw the equivalent circuit based on this particular concept. So now suppose to take V1, that is going to be HI into II plus HR into V2. So this is by the application of KVL, we can able to draw the equivalent circuit. So like that, suppose we are taking the next equation. So here the net current equal to the addition of two currents. So that is nothing but it is the application of KCL. So by adding these two currents, we will be getting the total current. So based on these conditions, we are going to draw the input equivalent circuit as well as the output equivalent circuit. So first we have to consider this particular voltage. So the net voltage what is going to be given to the circuit is going to be addition of these two drops. So that we can draw the circuit like this. So now the first time is going to be HI. So that is indicating the input impedance. So the normal impedance is denoted by the resistance. So that you have to consider the resistance. So that is denoting the input impedance of the amplifier. So that is going to be HI. So the current flowing through this particular resistance need to be marked by I1. And here this HR. So HR is actually denoting the voltage gain of the amplifier. So that is represented by the voltage source. So that is going to be plus minus. So here we will be having HR into V2. So this is the equivalent circuit. So there is a net applied voltage what is given to the amplifier, and this is this particular drop, and this one is this drop. By applying the KVL, so the total applied voltage equal to the drop present across here plus the drop present across here. So by considering the same case in the output equivalent circuit, we will be getting like this. So the output current is nothing but it is the addition of two currents. So the output current I will be taking it as I2. So in which, so the first thing is HF in the I1. So here the HF indicates the forward current gain. So this can be represented by the current source. So here this one is the incoming current. So the branch current should be outgoing current. So that you have to take it like this. So HF into I1. So this is belongs to the first term, and then second term is going to be H naught into V2. So H naught denotes the output admittance of this particular circuit. So the H naught is output admittance means so the reciprocal of impedance. So the admittance also represented by using the resistance only. So that you have to take the resistance in order to represent the admittance. So the V2 is representing a output voltage. So this is the V2. So this part is dealing with the input equivalent circuit, and this part is dealing with the output equivalent circuit. So by combining it together, we will be getting the combined hybrid equivalent circuit. Equivalent circuit. So this is the generalized model. So we want to specifically represent this particular model for any specific amplifier. Then we have to do some changes. So for example, the suffix we have to include. For example, if we want to apply this particular same H parameter equivalent model to the common emitter configuration. So here we have to denote like this. In the suffix we have to include E. So that we denote the common emitter configuration. So HIE into I1, HRE into V2, HFE into I1 and HOE into V2. So like this we can apply the same model transistor BJT model for any type of configuration. So this particular H parameter model is useful while doing the transistor AC analysis. So if you want to do the AC analysis of the BJT, so the BJT need to be represented by its equivalent model. So for this H parameter model is useful. So why we are going for this H parameter model instead of the Z parameter or Y parameter means? So the most of the transistor manufacturers are representing the transistor parameters by using this H parameter model only. So that the H parameter is useful to analyze the transistor amplitude.